morning, everybody. How's it going? That's great. It has been almost a full year since we last met. Who was here last year? That's beautiful. All right, so I'm really glad to be back here. And today's talk is the next 5 years. And why the next 5 years, right? So a very quick timeline of how things allegedly happened. So in 2011, Elixir started. At this point, it was we already had a name. It was Elixir, but it was very different from the Elixir that we all know today. So a bunch of prototype experiments. And then throughout this period, at some point, there was a vision of what Elixir as a programming language could be. That's when I went to Platform Tech, the company I work for. I'm one of the co-founders. And I said, hey, I have this idea of this programming language that can solve some particular problems in a very interesting way. And I asked them, let's do this. And they said, yes, let's do this. So that was the very beginning of 2012. And then 2 years and a half later, we released Elixir 1.4. Oh, 2014 released Elixir 1.0, the first stable release. And last year, when we were here, right, Elixir 1.5 was just out. And at that moment, it was 5 years since I started working on Elixir full time. So the keynote last year was pretty much looking back and kind of looking at what happened and revising our goals and where we want to go. So I thought it would be really nice for this year to kind of now. So if the last year we're looking to the 5 years before us, so what if we look to the 5 years ahead of us, right? So now we are here, 2018. Elixir 1.7 was just out. So and we are going to talk about Elixir 1.7 and then look at the 5 years ahead. So what is the agenda for today? So as usual, I always give a very quick update on what happened on the latest Elixir release. Then we're going to talk about ongoing efforts. So if you have been following what is happening in the community, and especially what the Elixir core team has been working on over the last year, we have started a bunch of different efforts. I'm going to give an update on all of those and share some new things as well. And then we're going to talk about the next 5 years. So Elixir 1.7. Elixir 1.7 was just out, and it was a minor release. And it was a minor release in two ways. So it was a minor version bump from 1.6 to 1.7, but also because it was really a minor release. There was no new flashy features, right? It was continuous improvement, iteration of everything we have. So, and that's what we should expect. And we're going to talk about this a lot in this talk, that's what we should expect from the future release as well, right? You're not going to have a lot of new things, modifications on how you write Elixir software. We're just going to continue improving what is in core right now. And so it came out in July 2018, and we are getting close to 800 contributors. The whole Beam community, right? We are past 7,000 packages on HexPM. We are getting close to 300 million downloads. That's a lot of zeros. Right, so we are growing, right? We continue growing in all the senses. When we look at the code, right, the contributors are growing. When we look at the packages, when we look at the meetups, and it has been a really healthy growth so far. It has shown some pains. We're going to talk about this as well throughout the talk, right? But those are very good signs, right? And when we come to Elixir 1.7, the major feature, so there are a bunch of smaller features like improvement to logging, improvement to the test framework, but the major feature that was in Elixir 1.7 was actually that we adopted EP48. EP stands to Erlang Enhancement Proposal. So when Elixir 1.5 was out a year ago, one of the big features of Elixir 1.5 was that we actually standardized how all Beam languages store AST, or your code information in the Beam chunks. So that has been standardized, so it's easier to write tools that work across all Beam languages. And the idea of EP48 is to do the same thing, but for documentation. So this was a proposal written by myself, Eric, and Radek. And the goal is literally to standardize how Beam languages, they're going to store and format documentation So we can have tools that work across the whole ecosystem as well. So what does it mean? For example, today, if you are using the interactive Elixir shell, you can say H and type the name of an Elixir module, and it brings the documentation. But if you do H and type the name of an Erlang module, that doesn't work. Now that we are standardizing how the documentation is stored and formatted, this is going to work in the future. That's the plan. So we did this proposal of the format, and then we implemented it for Elixir itself. And so it's a long-term effort, right? So Elixir implemented it, and we are waiting for the other languages to implement it as well. But in the future, we hope that they're going to have this interoperability working. But we don't need to wait for the future to reap the benefits of this change. So one of the things that this change made possible is actually the addition of documentation metadata. So for example, we use attributes like @doc to document a function. But now you can also pass metadata like what are the authors of this function? When was this function added? So you can add any kind of metadata to the documentation. And we are already starting to use this metadata in some places. So for example, now in the Elixir documentation, if there's deprecated functionality, before we had to write it in the text of the documentation itself, like this is deprecated. But now with the metadata, you use the metadata to say what is happening, and now the XDoc tool to generate docs get that metadata and put there in the docs, right, to make it easier to browse. If we have the metadata, you can navigate now everything that is deprecated. There are a lot of interesting things we can do. The other thing is that, I don't know if you can see it, I apologize if the example is too small, but also now on all of the functions that we have in our documentation, if you look at the top right corner, there is a since saying which version that thing was added. So people who write Elixir libraries, sometimes you're in a scenario, you wrote a piece of code, and then the CI fails because the piece of code you're using was using recent Elixir features, and you're like, okay, so which version do I actually support? Now, before you had to go, I did this many, many times. I had to go through each version of the Elixir documentation and say, hey, does this thing actually exist in the documentation? But now it's just there. You can see when it was added, and there are a bunch of other XDoc improvements that are on the pipeline. All right, so as I said, it was a really minor release, a bunch of small improvements, nothing really big. And because what we should expect is that the work on Elixir is starting to, not a lot of things are happening there, but actually the things are going to be happening on the community, on the whole ecosystem, right? So I want to talk about a couple of things exciting that happened. So for example, meanwhile, in the community, and I cannot possibly cover everything, okay, that happened in the community. So just some general highlights, like we got new podcasts, more people talking about Elixir and discussing Elixir. We were talking about documentation. We got new XDoc versions. We as a community, we are proud to say documentation in Elixir is first class, right? And those improvements continue to show that it's first class. It has always been first class. We are continuing to improve it, right? We are not satisfied. Something that also happened is the release of Erlang OTP 21. So, and there are a lot of nice things in this release, but one of the nice things is that the runtime in some benchmarks got from 5 to 10% faster, and that actually revealed to. So, as a result of this, compiling Elixir code in some cases got from 15 to 20% faster as well, right? So this is really great because I tend to worry, myself and the Elixir team, we tend to worry a lot about compilation times. And it's not that compilation times, it's a problem to the majority of Elixir projects, right? But if we can make it faster, right, why not? Like, if I can make everybody in this room, at the end of the day, wait 1 minute less, right? It's 1 minute that we all get productive. And then if we multiply that everybody in this room, we can see, yes, it pays off. So it was really nice that Erlang OTP resulted in faster compilation times, the new version. The next Elixir version, 1.8, should improve things about 5% as well. I know that the Phoenix team is working on changes for the next Phoenix version to improve this as well. So it's really great that, again, it's not a major concern, but we are continuing to improve on it, right? Again, we're not satisfied, and if there are improvements, there are changes we can do, we'll take them. So in the community, also what happened is that over the last year, right, we got Nerves 1.0. I believe that right now they are on 1.3 or something like that. We got new Phoenix versions. We're probably going to have new Phoenix versions out soon. and a lot of other things, right? And there are two things in particular that I would like to share with you that I am personally like very, very happy, and I'm going to tell why. So the first one is the Elixir mini documentary by Honeypot. So we have a lot of ways that you can learn Elixir and you can understand what it is, or you can refer to somebody to explain what Elixir is about. But we never have a visual way, like a video where somebody could sit and listen. And the Honeypot team, they did a fantastic job on this. So, if you want to get somebody, if somebody asks what Elixir is about, and you want them to understand what Elixir is about, what is the community is about, what is happening in the community, this is a very great mini documentary, a very great video. So I'm really happy with how everything came to be and with the end result. And the other thing that I'm really happy about is about the announcement of the membrane framework. So now, if you ask me what it is, I have no idea, okay? And that's actually why I'm very happy about this, because when I started to do Elixir, like one of the goals was that we want Elixir to be an extensible language, right? So it is supposed to have this small core, and everybody's going to build around it. And I knew that I would like to get Elixir and extend it to at least one domain, which was a domain that I have a lot of expertise on, which is the web domain, right? So, or maybe two domains if you consider like talking to the database, SQL as a domain itself. So I knew I wanted to expand, I knew I wanted to get Elixir and extend to those areas. And that's why, for example, when you look at Acto, it's one of the oldest projects in the Elixir community because we used Acto to validate the language itself. So, and it worked, and then we're like, hey, this works, right? But, there could always be a bias because, well, it works for Acto because I kind of knew in my mind that that's a domain I wanted to work on anyway. So, yeah, it works. And then Chris came with Phoenix, and he did the web, but he added the whole idea of real-time. And I was like, hey, this is very interesting. And then it came Nerves that I also have no idea about and I find fascinating, right? That is getting Elixir and extend it to the domain of embedded software. And I was like, so, it's a validation of the goals of the language that we're able to achieve it. And now the membrane framework is getting Elixir and extend it to the domain of reliable and scalable multimedia streaming. Right? And it's like, this is fantastic, right? Because it's showing that again, they are getting this small core and they are extending it to different areas. And throughout the conference, you're going to see other examples, like Boyd is going to talk about the Y framework, Cynic. So all of these, I find it very fascinating and very exciting. All right, so those are some improvements that are happening in the community. We also saw some improvements on the website. And this is an interesting story. So over the last year, so everything I'm saying happened over the last year. So we started to hear some things. So one of those things is it's harder to contribute to Elixir. And then we'd talk to people, try to understand, where the sensation is coming from, why is this happening? And then we got some feedback, and then we realized that, this is actually true. It is harder to contribute to Elixir, especially if you came before Elixir 1.0, where the language, and here by Elixir, I mean the Elixir language, the language itself, this is small core, right? So, and I said, it makes sense, right? Because if you came before 1.0, the language, this core was still being shaped, so there was a very high chance that it could come and cause an impact and shape how this small core is going to be. But after 1.0, right, this thing, what we all expect is that this core is going to change less and less because we want now for the whole community, for the ecosystem, to start building around it. Right? So we said, you know what, it actually makes a lot of sense, especially with Elixir in that, so I say that there are two ways you can consider a 1.0 release. So one way is to say, hey, we are releasing the 1.0 version of the software. And this is kind of the starting point, and we'll continue building on this. And the other way is to say, hey, this is like the 1.0 release of the software, and this is pretty much close to the real deal, right? This is the package. Sure, that we'll continue improving, continue iterating, and we have done this throughout the years, right? But that's the core. And Elixir was always the second one, okay? So it does make sense it's harder to contribute to Elixir. And not only that, the community grew, right? And then there are less things to do. So the laws of offer and demand, they're not very kind here, right? It's actually great as the maintainer of the project. Sometimes we open up issues with things I would like to have in the language, and then it's tackled within 24 hours. There's a pull request. We just need to review it, test it, and merge it. So it's really exciting. So we agree, it is harder to contribute to Elixir, but the lesson here is exactly that we should all build around this core. That's where the focus should be, right? The focus is in the community, is in the ecosystem. The other thing we heard is, I'm glad the core team is more transparent now. So this was really curious because for better or worse, the amount of transparency in the Elixir core team didn't change. It was like constant all the time. So we started again talking to people and tried to understand why there is this impression. And when we were talking to them, we said, but if you want to know what is going to be in the next Elixir version, all of the major features, we actually discussed them in the mailing list before and in the Elixir forum. Everything that we plan to have in the next Elixir release, it's actually in the issues tracker. And then we would tell this, and people would say, oh, so there is a process. So it became clear that at the beginning when the community was small, people probably came to use Elixir and learn Elixir through just a few ways, and they could eventually reach to the repository and from observation kind of understand that there is a process of how things happen, but it was never documented, this process. So it was clear to us that this fluctuation, like in this transparency, is because the process was not written down, so it's unclear what to expect from the team. So based on this feedback, we've added a new page to the website. So if you go to the website, on the menu at the top, there's a development page. And there we outline all of those things. Why Elixir existed, how it started. It tells about the goals of the language, that we want exactly to be an extensible language, and the focus should be in the ecosystem and in the community and everything around it, right? We talk about the process. If you want to change the language, you want to submit something, this is where you go. This is where you do security reports. Everything's there, right? And it's a small change, right? But I think a small change in terms of effort, but I think it really brings a lot of visibility to the whole process, whereas sometimes it was not clear to a large part of the community of how those things work. All right, and there were also improvements at Platform Attack that I would like to share with you. So for those who are not familiar, Platform Attack is a software consultancy based in Brazil. I am co-founder and director of research and development at Platform Attack. And as I said, Elixir started as a research and development project inside Platform Attack in 2012. And in 2016, it was when we started to have our first Elixir projects with clients. And we got a lot of feedback in this process. We talked about this last year as well. So we would have experience with those projects, and we would get feedback. Sometimes this feedback would lead to language improvements. Sometimes it would lead to getting started improvements, and so on. And some of the feedback that we got as well was feedback from our own services for us as a company. And a very common feedback that we got is that companies, they would like a way where they could rely on the team, the engineering team, and the expertise that the Platform Attack team has on Elixir constantly over long periods of time. And it's exactly based on this feedback that at the beginning of this year, we started a new service called Elixir Development Subscription. And that's exactly the idea, to have a direct communication channel between your engineering team and our engineering team, so you can build Elixir applications with speed and confidence, right? Because when we are learning a new technology, and any new technology, it's common to have questions what is about the best way to implement something, what is the best way to integrate the technology with your existing systems. And then if you have a team that can provide you support, code reviews, assistance, take part in technical meetings, it helps speed up this process and give confidence a lot. So I don't want to go a lot into this. If you want to talk more, I'll be around the event. There's also Hugo with the Platform Attack Sure. We have a desk, right? But one of the reasons I'm excited is that since the service started, we are working already with more than 10 companies throughout their Elixir adoption lifecycle. And the Elixir Development Subscription, it also led directly, it was one of the things that led directly to the next thing I want to talk about, which is that Wojtek Ma, he's joining the Platform Attack team. Right? So the reason why this matters, and I'm actually very excited about this, right, is because when Platform Attack started to invest in Elixir in 2012, I was the only person working on it full-time, okay? So it was me for those last 6 years. And sure, there were a lot of developers at the company that contributed to Elixir directly and indirectly, but full-time it was only me. And now with Wojtek joining the company, we're actually doubling this research and development team, right? So it's really exciting for me, and it may be exciting for you as well, because I was used to do this joke that I was responsible for a huge department of one engineer, and now I can't make this joke anymore, and I know a lot of people appreciate not having to hear this joke again. So yeah, so I'm really excited to have Wojtek Ma, because we have a lot of ideas and things that we want to explore as well in the community, in the ecosystem, and having somebody else join the team means that those ideas, right, is going to come on to appear, and they're going to become concrete sooner, right? So yeah, we'll see what's going to come in the next years. All right, so that's it. So that's kind of like a very long update on everything that has happened throughout the last year. And now I can talk about the ongoing efforts, right? So as I said, the Elixir team, we were kind of like working on different things that we were studying to be part of the language or not be part of the language. So you probably heard about those things already. So the code formatter, property-based testing, XHTTP, and releases. Those were the 4 main fronts. And it would be good before I start talking about those things, right, to think like, well, if we're talking about features that we eventually want to make part of Elixir, right, what is the criteria for adding features to Elixir? And luckily now, we have a page that outlines those criteria precisely. And this page says that the criteria for new features is that we'll add new features to Elixir if they are necessary for developing the language itself. Okay, so if we need that feature as part of the language, then we need it as part of the language. There's not much we can do. So the whole reason, like the EX templating engine, it's part of Elixir, it's because we need it in other parts of Elixir. Otherwise, it could just be a separate package. Okay, or the feature bring important concepts, features to the community in a way its effect can only be maximized or leveraged by making it part of the language itself. Right, so for example, JSON. Who here needs to decode or encode JSON? Right, like almost everybody in this room needs to do that. So, but why is it not part of the language? Because if we add JSON to the language, there will be no difference in the user experience compared to a package, right? You just add one line to your mixxs file and done. That's it, right? There is not a very big difference. So it doesn't make a lot of sense to make it part of the language, because again, we want to have this small core, right? We want to have this small core and build around it, extend it. So that's the reason. And there are 2 guidelines that the Elixir core team follows. So the first one is extensibility. So again, the focus for us is to enable rather than provide. We want to make sure that things are possible, right? And then you can get it and twist it and shape it in any way we want, right? So we want to enable rather than necessarily provide that feature. And we are also conservative, right? I always say adding is easy, right? It's very easy to add code. Removing code from Elixir, it's very, very hard, because if we just remove code, we would break the language, right? To backwards incompatible. We can't do that. So if you are not sure, we just postpone it, right? Because we can always add later, but removing is really, really hard. All right, so let's talk about those ongoing efforts. So the code formatter. And I promise this is the last time I talk about the code formatter. Not going to hear me talking about the code formatter and any other event anymore. Okay, so what is the code formatter? It was released in Elixir 1.6, and it formats your code using a consistent style. And it helps you focus on what matters, right? So, sometimes you send a pull request, and there are a lot of comments about the format of that code, how to style it, and you should rather be spending that time. So somebody needs to write that comment, so another person needs to read and act on them. And when you run the formatter, a lot of those issues are solved, and you can focus on the design decisions, on the business logic, and so on. And it also works as a guide for newcomers, right? Because if you're learning a new programming language, one of the many things that you are worried about is like, hey, does this code style-wise look like code that the community would write? And now with the formatter, you get like immediate feedback. So that's how the formatter works. And what is the motivation for having the formatter in Elixir itself, right? So does it fit the criteria that we were talking about? So the first one is that we need a formatter to format Elixir itself. As the Elixir core team grew, it was very apparent to them that I followed no consistent style whatsoever. So we started to have a lot of discussions, right, about the format. They would ask, why you wrote the code like this? And I'm like, I have no idea. Like, I guess it looked prettier at the time. And so, we would have those discussions and on how to improve formatting in general. And the other thing is that it also made it a little bit tricky to accept contributions, right? Because one of the things that I never wanted to have in Elixir is to have a style guide, because I don't think it's a welcoming experience if you have to ask somebody, hey, you need to read this long document, boring about styles, before you can make a contribution to this project. So they would often write pull requests, and then we would merge those pull requests as is with a style that we don't agree with, and then we would then readapt the code to the format that we thought would be the Elixir code-based format. So there was a lot of time spent on this as well. And then we thought, well, if we have the formatter, now we can just tell everybody to just run the formatter. If you send a pull request and did not run the formatter, the CI is going to fail, right? And then it's going to be easier for everybody to contribute, and it's going to be easier for us to accept those contributions too, right? So that was one of the reasons. And the second one is that one of the goals of the formatter is to unify the code written by the community, and it's easier if we do that, if it comes from the language itself, okay? However, I think it's exactly this second goal that led to a little bit of friction, because we talk about this in the documentation, is that you can't use the formatter blindly. So since this is the last time I'm going to talk about the formatter, I'm going to use this opportunity to talk about this thing very quickly, and then we can move on eternally. So this is a true story, okay? So this is a true story that actually happened. Somebody came, I don't remember if it was on IRC or in the Elixir forum, and they said, hey, I run the formatter and in my code, and my code now looks ugly, right? And they're like, yeah, let's take a look at this, right? Let's see how we can improve. And this is the code. Okay, so they're really nice. After all of this, we asked if we could use this example in the documentation. So it is in the documentation as well. So here's the code. I know you can't see it, right? That's kind of the point. Because why it's happening here? It's a very long code. Okay, so it's a very long, complex expression that is kind of written in two lines. And the developer, when they wrote this code, they were probably relying on a very long line length, or they were relying on the fact that their editor could wrap lines to have this very complex expression in a single place. So when you run this through the formatter, this is what you got. The formatter would not accept that, right? So it's going to break into a bunch of lines. And so now that code that you would think, oh, it was so concisely in 2 lines, right? Now it's like taking 6 or 8 lines, and then this is ugly, right? While I personally prefer this code, right? That's not the point. And you may prefer the other one. That's totally fine, right? The point is there is no formatting that it could possibly apply to this code that is going to make this code actually readable, okay? But it's true, right? There is, and again, like, I am guilty of this. You can ask, there are members of the core team here, and you can ask them a bunch of those cases. So for example, we had functions in the Elixir code base that would take 8 arguments. Who think having a function that receives 8 arguments is a good idea? Apparently me, right? But that happens like on every day. Like, oh, you start with a function with 4 arguments. Nothing starts with 8 arguments, right? That would be really bad. But so you start with 4, and then you add 2, and then you add 2. You have 8. And then before, without the formatter, we are just adding something like, oh, I'm going over the line length. It's fine, right? It's not a problem. I'm just cheating here. And then when you run the formatter, because it go over the line length, it would put each argument on its own separate line. And I'm like, hey, this looks horrible. Right? So one of the reasons I like the formatter is that it actually helps me keep honest. So when we look at those cases, we said, well, actually, just running the formatter here, it's not good enough. We actually have to refactor the code. So the formatter is actually helping point flaws in the code by having this strict guideline. And that's what we did, right? So for this code, we were working with this developer, and then we said, hey, what if we get, so I don't know if you can still see it because it's still a lot of code, but basically it is one expression and another very complex expression. So what if we get this end here, the second argument to the end, and move to a separate function? So we did that, and when we moved to a separate function, we actually understood what that code was doing, and we could optimize it to something that actually is faster. So to me, the code became better formatted, it's better to read, and performs better too. right? I'm not saying that the formatter is never wrong, right? Like there are cases, so for example, if you're working with tabular data, like I'm sorry, it's just going to wreck your tabular data, right? So, but that's the lesson here is that you don't run the formatter blindly, right? It's a tool. The documentation go over different cases where you can give hints to the formatter, and that will lead to a better end result. All right, it's over. The formatter is past us, right? So it's part of the language. It's going to continue to be part of the language, right? But I wanted to share because the formatter has been also a very big learning exercise and experience for me because the first time I use a formatter as well, and I'm always like surprised when I'm learning those lessons, and I wanted to share it with you. All right, so the second thing that we are talking a lot about adding to Elixir is property-based testing. So I'm not going to go into a lot of details about what is property-based testing. But the basic idea is that the examples that we write today when we're writing tests, they are example-based tests, right? If you want to test a function, you have to come up with a bunch of examples in your head, and then you're going to call this function with those different arguments. You assert on the output, and that's it. With property-based testing, you don't come up with examples. You actually write properties, things that should always be true. So for example, imagine that you want to test string contains. That checks if the string given as first argument contains the string given as second argument. So a property that I would write is exactly this one. So it would say, well, imagine that I have a string as left argument, and I have a string as right argument. If I concatenate them, this concatenated string should contain the left side and the right side, right? So this is a property. It should always be true. Okay, so we don't have to come up with examples anymore. We define the property, and now when you run this property, it's going to generate a bunch of examples randomly and on the fly, and it's going to test your function under different scenarios, possibly helping you spot bugs. So property-based testing is sometimes known as generative testing. You got it. Generative testing. It's useful to describe the invariants of the system, right? Things that should always be true. And the reason why we're very excited about property-based testing is that it actually helped us spot bugs in the Elixir standard library. So we're thinking, hey, if this is helping us be better developers, and we have included a lot of the property-based testing vocabulary in the issues tracker discussion and discussions with the core team. So if this is helping us be better developers, it's probably going to help the whole community to be better developers too. And that was the main motivation for having property-based testing as part of Elixir itself. So in a way, it's needed for designing Elixir. And the second one is, again, to promote best practices in the community. But as we talked and we investigated more and more, we actually started to evaluate those points. So the first one, is it really needed, like is it really required for designing Elixir? For example, sometimes we're going to implement some feature in Elixir, and we have two ways to implement this feature. And what we do is that one of the ways we can do is that we say which one performs better. So we need to do benchmarking. So we bring an external package like Benchy to do those benchmarks. We compare those results, and then we say, hey, here's the conclusion that we got from those benchmarks. Okay? So are we discussing to have Benchy as part of the language? It's a great library, but it's fine as a package. We're not discussing it to be part of the language because when we need it, we can bring it, right? The fact that we know that it is a tool that exists and we can use it is the most important part here. So, we thought that, the same thing applies to property-based testing. We're not going to use property-based testing on everything for Elixir. It's a very useful design tool and a very useful testing tool, but we can bring when it's necessary. When we are designing new APIs, we can talk about properties and so on. So after we thought about this, we thought, well, it is a great and excellent tool to have and a great technique to learn and have in your mind, but it can be brought in when necessary. It doesn't have to be part of the language, right? And the second one is that if we're going to promote best practices in the community, which library is the best practice? Because we have more than one property-based testing library in a language. So which one are we actually going to pick and to promote, right? Because they do different trade-offs, and those are trade-offs. One is not necessarily better than the other. And the other thing is that awareness grew a lot in last year. So for example, at ElixirConf this year, we're going to have 3 talks on the subject of testing. 2 of them are about property-based testing, and one is about software verification and testing in general, right? So recommend watching the talks and learn more about property-based testing as a whole, right? And we also, there is this book released by Fred Hebert, and He's the author of Learn You Some Erlang, of Erlang in Anger, and it's a really excellent book about property-based testing with proper Erlang and Elixir, right? For those reasons, we have decided that we're not going to include property-based testing as part of Elixir itself. Okay, so string data, so the update here is that string data, which is the Elixir implementation of property-based testing, is going to remain as a library outside the Elixir Lang organization. So Andrea is the one, Andrea? He's there. He's the one leading this effort. And who continue to lead this effort. There are still a bunch of interesting ideas to explore. And you can still go contribute, make your dent in the package, and help design and guide the package. And we'll continue to work on this, but not as part of the Elixir Lang team effort. Okay? So I just want to say this, right? I still think that the idea behind the string data, it's very interesting. Because the other libraries, they are property-based testing libraries. Their focus are on the property-based testing parts. But with string data, we kind of like flip these things around. It's like, what if we put the data first, and then we can derive interesting properties out of it? Right? So one of the things that if we put the data first and we derive interesting properties out of it, one of the things that we get is property-based testing. But we can get other things. So I still think there is very worth exploring this view of property-based testing of data generation in Elixir. And we can continue to do that as a community with the package. All right. The other effort is XHTTP. So what is XHTTP? Is an HTTP client that does not prescribe a process architecture. What does it mean? Every time you use most of the HTTP clients packages that we have in the community, if not all, they all come with a process architecture. So when you do a request, you actually send a request to another process or to a pool that is going to coordinate with something else, and then you do a request, and so on. The issue with this is that, for example, if you want to, imagine that you want to consume data from a Twitter firehose or any HTTP client or any HTTP API, right? So for example, if you're using GenStage, which is one of the abstractions we have in the Elixir ecosystem, you would have something like this. You would have the Twitter API, for example, and then you would have the HTTP client as a separate process, and then we would have the GenStage process. So we have this process in the middle that is not adding anything, right? It's just overhead, it's just indirection, just more places for things to go wrong. So the thing is, what if we could merge this GenStage, for example, with the HTTP client and have this to be one thing? And the way we figure out we could do this, like, well, what if we have an HTTP client that does not prescribe a process architecture? It's like a very thin wrapper around the socket, okay, the TCP socket. So that's what we're exploring with this library. And we're also exploring ways to unify the mechanisms to interact with HTTP 1 and HTTP 2. So we are considering having this library as part of Elixir, right? It's not meant to be a full-featured HTTP client, right? It's the building block, okay? And what is the motivation for having an HTTP client in Elixir itself? So it's needed in Elixir, right? There are a bunch of tasks that we do, like archive install, script install, local hex that is going to install hex for you, and local rebar that installs rebar for you, that they need an HTTP client to get those things, right? And the OTP team, and why we don't need HTTP, why we don't need this library today, why we don't have it today? Because we use an HTTP client that ships as part of the Erlang OTP. It happens so that the Erlang OTP team, they have been talking for a couple years, and the latest release was last time this actually became true, that they've been talking a couple years about breaking Erlang OTP apart into a bunch of separate packages. And this Erlang OTP 21, it happened for the first time. They took a bunch of the Corba stuff out, don't ask, and they moved it to a separate package, right? So we thought, well, there is a chance that they may remove the HTTP client, and we need to be ready for this. Later, we ended up talking to them, and they said, like, it's unlikely they will actually remove the HTTP client. Even if they remove the one they have today, they'll have a very thin, lightweight one. So it actually turned out that we don't need to worry about this scenario. So we have announced XHTTP, but throughout the last year, again, we discovered that, well, it may not necessarily become part of Elixir, so the efforts, they're going to continue outside of the Elixir language. And Eric is around here, and he's the one leading this effort. Andrea is helping as well. So if this is an area that you are interested on and you want to contribute, get started with the project. Again, I really think the idea, it's very interesting. It has a lot of potential right? So if you can have something small that everybody can build on top, right? There's a lot of potential in that, so I definitely recommend exploring it. And the last ongoing effort that I want to talk about, they are releases. So releases, they are the best and the safest mechanism to deploy systems in Elixir still. And it will eventually become part of Elixir, right? Because it's part of our Erlang OTP, so we just need to put the Elixir makeup on it and have this fully integrated, okay? So it was always in the plan to do this, and we have made good progress, and by we, I mean the community, as we're going to see, over the last year. So one of the things that we did is that we had a huge discussion in the Elixir forum about configuration. How are people using configuration? How should we change configuration? What is the difference between compile time configuration and runtime configuration? And as Brian said just before the talk, so Paul and Dockyard, they recently announced Distillery 2.0, right, which is a major improvement to how the release process is happening in the community and exploring those ideas of how the configuration should work. So there's a lot of exploration, a lot of feedback happening here, and you should try it out and give feedback to Paul and continue to improve this, right? So really nice and fantastic work coming from Paul and Dockyard here. And the goal is to eventually, right, to have Elixir releases as part of Elixir core. So regarding release, we had a lot of progress in the configuration front. Right now, we are doing experiments with our Erlang OTP to simplify things. So there are a couple of things that are going to be simpler and more efficient if we change our Erlang OTP. So we are playing with those ideas. Maybe it will become a pull request, and we can get it merged. We'll see what will happen. And overall, what we want is that the releases in core, they'll have a smaller than Distillery, right? Again, the goal is to enable rather than provide. So it may not come with all the bells and whistles that Distillery has, but the core will be there. Right? But for now, it's still ongoing work. Paul is the one that is working on this. So, and for now, the best way to go is still Distillery, right? So continue using Distillery, and we'll keep you updated in the progress. Right, so if we look at the ongoing efforts, it's actually a little bit, if we're looking for flashy new features, we were warned at the beginning of the talk, but we got the code formatter. We decided that property-based tests and XHTTP is going to be built as part of the community, and releases is ongoing. However, there's one last ongoing effort that has happened over the last year that it's actually not on the list, and we haven't talked about it in the past, that I would like to share with you. So what is this? So there are two things I would like to share with you, right? The first one is that we started working on a type system. Wait. The second one is that we stopped working on a type system. The lesson is always wait for all the bullets to come out before clapping. All right. So, yeah, so type system. This is a very long topic. There is no way I can do justice to this topic in 10 minutes that I'll try to talk about this. But I thought it's important for us to talk about it. I know there are people that are exploring those ideas. And since we explored a little bit ourselves, I think it's fair from us to share what we have learned with the community. And hopefully somebody else is going to pick up those learnings and is going to try something different, and so on and so on. So very broadly speaking, right, is why have static types, like static type checking in Elixir? So when we ask people why they want that, the biggest thing they want is detecting errors by a type checking, right? They want to detect errors early on. And usually here I do a disclaimer, right? Because you can detect errors early on, but there is no type system in the world that is going to protect you from all errors, right? So you also need the safety mechanism that when, especially if you're talking about distributed systems or things that run over the network, right? Suddenly the database disappears for 5 seconds. It's a mystery, right? But it disappeared, and we need to be able to cope with that. So having the fail-safe mechanism, the fault tolerance mechanism that we have with Elixir today, it's extremely necessary, right? And a static type system does not erase that. It would actually complement that. It would help some bugs not come into production, but they are still going to happen. That's life, right? And we need those mechanisms to in place. But if we can detect the errors earlier, why not, right? Depends on the cost of having this, but if we can have it, and assuming it's fast, it's productive, it's good for our experience as user of the language, why not? So that's the major thing everybody talked about. The second one is documentation and tooling. And we already get improvements related to documentation tooling because we have type specs in the language. And there are people like Luke with IntelliJ and Jake Becker with Visual Studio Code that is doing great improvement, great progress in those fronts about improving documentation and tooling in regards to types and everything else, to the type specs and everything else. But we can still improve, right? And possibly a complete type system would allow us to improve even more. So it's also something I would get. And the third thing is efficiency and performance. But this is not going to make a huge impact in Elixir. Sure, we can improve a couple things, but generally speaking, it's not going to be life-changing in any way, right? Because you're still running the Erlang VM that is working with the dynamic types in a way, so we don't have a lot to leverage from this particular area. But those are kind of like the features that we expect from having a static type system and in the order that the community finds it more important. So what is our attempt, okay? So our attempt was to accept as much Elixir code as possible. So if you want to have a type system in the language, in an existing language, one of the things that we want to do is to have to change this language as little as possible, okay? So that's one of the things that we went like, this is what we want, right? And for this, we're going to perform local type inference. So what it means that you would write a function, and even if you don't put any type for those functions, we would figure out the types for you. So, so when you look at this, it's like, it's the absolutely no compromise approach, right? Like we want to type all the Elixir code we have right now, and you don't even have to add the types, right? This would be magic. So, and we want, in a way, that typed code can only interact with typed code. So it would be closed. After you go to typed code, you need to leave in typed code, okay? So what is an example of how this would work, okay? So imagine we have this code, and this code is totally no sense. It doesn't make, but it's enough to show a point here. So imagine we have this module called converter, and we have two functions written in Elixir today. So the first one is int to a string that converts an integer to a string, and the other one is a string to atom that converts a string to atom. And then imagine that instead of using def module, we would now use something called def typed, okay? And when you use def type, we know that that's a typed module. And then if you don't define any types explicitly, we are going to infer the types for you. Okay, so the first function, we are going to say that that's a function, we can infer that that's a function that receives an integer, and it returns a binary, which is how strings in Elixir are implemented. The other one is another complete separate function that receives a binary and returns an atom. Okay? So we would do this, would get inference, it works, right? The problem is that in Elixir, we can write code like this. Imagine that we get those two functions and merge into one, just one single function, okay? So one single function with different clauses. So we have this function now called nonsense, that when it receives an integer, it's going to return a string. And when it receives a string, we need to return an atom. Now to type this, we need to use something, there are different ways to implement this. The way we choose is to use something that is called in literature as an intersection type, right? So we would say like, well, the type of this function here is, now that we're merging those clauses, is the intersection of the first clause with the second one, okay? So we started exploring this thing called intersection types, and we figured out that intersection types, they're very expensive in terms of inference, to the point of being practical, right? And I'm going to show exactly why. It's very funny because we worked on these, read a lot of papers about intersection types, we got a prototype working, and then we started to notice that everything was getting super slow to do the type inference. And then we went to talk to some professors, and then we would say, hey, we're using type inference, and it's very, very slow. And then they would be like, immediately, oh, they are known to be slow for inference, right? And none of the papers talk about it, none of the papers that we read, right? So it's very interesting because that's not the concern at this point with intersection types, right? They're still exploring if the things are decidable, how inference works. That performance is not a concern they have at that moment, but apparently it's a known thing, right? But we figure out the long way that that's the case. And the reason why is this. So let's take this example here. In Elixir, we have the AND operator, right? Logical AND operator. So A and B. If you're going to type this in Elixir, would have a type like this. It would be very close to the implementation, right? So how does it work? If the first argument is new, this thing returns new. If the second argument is false, this thing returns false. And then if the first argument is everything else, this thing is going to return whatever the second argument is. Okay? And the same for OR, right? So when the first argument of OR is new, we return the second argument. When the first argument for OR is false, we return the second argument. And then for everything else, we return the first argument, right? Now, if we have to write this code, AND OR, that receives A, B, and C, and computes A and B or C, imagine that we write this code, and we want to figure out the types for this. We need to consider 27 different combinations, right? Because we have 3 arguments, and each of the operators, they have 3 clauses. So it becomes 27 cases. And you can see that in a large software, this is going to become really bad, really, really fast. So that's what we learned. And then we said, OK, so if doing inference is expensive, what if we just require all the inputs to be explicitly typed? So we don't do inference anymore. We can do inference for the output, but all the inputs need to be explicitly typed. We tried considering this, and it just didn't feel like Elixir anymore, right? Because now you are in this def-typed thing that behaves kind of different. It requires inputs, and then depending on what you're going to do, right, so if you had a problem, it would have 2 different ways where you could tackle this problem, one that is typed and the other one that's not typed. And we just felt like this whole idea that we have of a small core, it would fall apart, like, because we would fork the language and have 2 ways to do everything. So that's why we stopped working on it. Okay, so what are my suggestions? And that's actually the main point of this whole thing. Okay, we should consider other ways. We should explore other ways. Gradual typing, there are a lot of people talking about gradual type lately. So if this is an area would like to explore type systems, I just showed you one direction that did not work, but there are a bunch of other directions to explore. Gradual type seems to make sense in general. And there's still a lot to figure out, right? We need to figure out how we're going to type processes, how we're going to do metaprogramming, how we're going to handle with the intersection type, like with the functions with multiple clauses. And there's actually one effort coming from Erlang, which is a project called Gradualizer, that is attempting to add gradual types to Erlang and would be able to benefit them from Elixir directly. So that's another area you could investigate, right? So when you look at all the ongoing efforts, right, we had a new one at the end that did not work. Locally inferred intersection types. That one did not work. It's not going to be part of the language ever. But the point here is not that we're saying we're not going to have types. We're not saying that we are going to have types, right? We don't know. But the point is that we tried something, and now it could be your turn to try something. Maybe we'll try something again in the future when we regain some breath, right? So it's really up to us, generally speaking, and not. And it can be that you're going to go home, you're going to explore a new idea, you're going to try it out, and next year you're going to be presenting at ElixirConf what you've tried, the lessons learned, and then somebody else can get those lessons learned and eventually can converge into something that we can all actually use. So this brings me to the last part of the talk. Ironically, it's the title of the talk, but it's the shortest part. So the next 5 years. And one of the things that when we were talking, I was talking to people and like, hey, what do you expect in the next 5 years for Elixir? One of the things that people talked a lot, right, where people came to their mind, like kind of the first thing, is Elixir 2.0, right? But I strongly disagree, right? Because so people would say, well, we're going to have Elixir 2.0 that's going to have like new features to the language that for some reason we can't have today, right? And the reason I disagree is because as we saw a couple times throughout this talk, Elixir was designed to be an extensible language, right? Again, the small core that we can build around it, right? And one of the focus was actually that we want to have the tools that we use to build the language to be available to the whole community, right? So if we need a major language version to change the language itself, then we fail to build an extensible language, right? If we need to release Elixir 2.0 to get up with new features, to make things that are not possible today, to make them possible, then it means that we failed, right? The language is not extensible. So in my mind, right, when we talk about Elixir 2.0, it's not coming anytime soon, okay? It's, if there are changes that need to be done, we can get the language, we can do those changes now, we can improve the language today, okay? And actually, from 2014, since we released 1.0, there is only one breaking change planned for 2.0, okay? And it's ridiculously minor change. It's the result of the doc attribute, something like that, that very few people rely on. And for me, this is really good. This is a really good track record, right? If in the last 4 years, that's the only breaking change that we have accumulated. And that's because Elixir is extensible, right? New features and best practices, they can be implemented today. And that's what we do, right? Sometimes we say, hey, there's a better way to do this. And then we have a new feature. And eventually, we deprecate the old ones, the old practices, okay? I know, that we do have deprecation warnings, so when you upgrade the Elixir version, you usually get deprecation warnings. But the plan is to eventually stop, right? Because, again, the small core, we are having less and less changes. Eventually, we'll settle down. So Elixir 2.0, if we ever have this release, right, the only goal will be to solidify best practices and remove deprecated ones. So ideally, except the handful of breaking changes that we may have. Right now, we just have one, right? But ideally, if you run Elixir 1.0 if you run your software, your application in Elixir 1. Something, the last Elixir 1. Something, and you don't have deprecation warnings, when you upgrade to Elixir 2, that thing is just going to work, right? That's the ideal, right? That's what we want. So, but again, we are not in a hurry, right? It's not coming anytime soon. So when we talk about the next 5 years, the last major planned feature for Elixir is releases. That's it. There is nothing else major planned, right? That's the last thing. It was actually there since the beginning, since 1.0. So if you go to ElixirConf 2014, 2015, we talk about releases, right? And that's the last major effort. New projects, ideas, developments, they belong to the ecosystem, right? And they're going to be explored by the community. It is going to be the Elixir core team, Phoenix, Nerves, Membrane, Scenic, any library that you're working on, right? It's going to be explored by all of us together. And that's what I want to share at the end, that the next 5 years, they are in your hands. Thank you very much.